where we have all the classes with the same amplitude is very easy because we only need to put the height of the rectangle equal to the relative frequency. And what is the idea that the histogram gives to us? What is the idea? The idea is, for example, here in the last class between 20 and 30, we have less values. And in the first class between 0 and 10, we have more values. Why? Because the area here is, we have here more area. So the area of this rectangle is 40% of the total area of the histogram, or of the complete area of the histogram. So, and this means that we have 40% of the data of the values between 0 and 10. So in this case it's easy. But now we go to do a second example. And in the second example we can understand better what is the histogram. So let me put here the number 2 example, sales, but now the last class will have more amplitude, not 10 but 20. Okay? So the first class is equal, 0, 10, the second also the same, 10, 20, and the third class now we have double amplitude, so 20 and 40. And I will put the same relative frequencies, the same, 0.4, 0.35 and 0.25. Now we will do the histogram here, and we will start with something that is not correct, something wrong. So the first class I will do the same. So I will put here 0.4 and I will do this rectangle. This. The second, the same, 0.35. And now, if I do the same as in the previous example, example number 1, I will put 0.25 for the height. So here is 0.25, but this is not correct. So I'm doing here something that it's not correct. Okay? Here I have 40 here. And if I do this, what is the problem? What is the problem here? What is wrong here in this histogram? If we look to this histogram, we have a wrong idea about the behavior of our data, because this area here, this area, it's not 25% of the complete histogram, so it's much higher. So and we are giving a wrong idea about the behavior of our data. So we cannot do the height of the rectangle equal to the relative frequency. So, because we have a different amplitude, and when we calculate the area, we have a much more high area. So we need to do a correction in these cases. In the numerical examples, I will only do one class with different amplitudes, well, only one. And usually we do that, for example, when we have extreme values. If we have extreme values, the values are much more higher than other or much more lower, and sometimes it's useful to have a class with much more amplitude to catch the extreme values. Of course, if we have more than one class with different amplitudes, it's not easy to do by hand the calculations, but the software do that easily. But in our numerical examples, when we do the calculations in the exercises, I will put only one class difference. So, and it's very easy, the correction when we only have one class. And how we do that? It's very simple. I will do here. So we need to correct the height of the rectangle where we have a different amplitude. So we will only correct that height. Okay? So I will correct this here. And how I correct the height? So the height will be I will do with this correction. I will start with the amplitude of the other classes. So I have here two classes with amplitude equal to 10, 10, 10. So I will put in the numerator, I will do a division, and I put here in numerator the amplitude of the other classes. So 10. I can write here 20 minus 10. 20 minus 10 is equal to this one. So I can put 10 minus 0. And in the denominator here, I will put the amplitude of the class that has a different amplitude. So what is the class that has a different amplitude? So it's the last one. And what is the amplitude of this class? Is 40 minus 20, so it's 20. So I will put that into the denominator here, 40 minus 20. And now I only need to multiply by the relative frequency, that is 0.25. So the correction is very easy. Okay, we put here a division between, in numerator we put the amplitude of the other classes, and in the denominator we put the amplitude of the class that has a different amplitude. For example, if here we have like not 2040 but 2060, what we need to do? Here we need to put 60. So the amplitude of the class that now has a different amplitude now is 30. So this is very simple to do. It's an important exercise because with this exercise we can understand very well what is the rule of the histogram. Okay? So I will do this correction. These calculations, what we have here, 1 divided by 2 times 0.25, the result is 0.125. Okay? So now the height of the last rectangle, I will put only 0. It's more here, 0.125. So and now we have the last rectangle, and now we are giving the correct idea because this area is now 25%. The area of this blue rectangle now is 25% of the area of the complete histogram. So if you calculate the area of the total histogram, and then this area here, and we divide this area by the total area, the result will be 0.25. So now we are giving the correct idea. When we look now to the histogram, we have here this area equal to 25%. So we are giving the idea that between 20 and 40, we have 25% of the values. Here, this area is now equal to 25% of the complete histograms. Now we will move on to the last example where we will deal with empirical quantiles. So I will put now the last example, example number 3. Again, I will put sales, but with 5 classes. Now between 0 and 10, 10 and 20, 20 and 30, 30 and 40, and 40 and 50. And I will put now already the relative frequencies. So I will put here small f. Let me put here, I think it is 0.3, 0.2, 0.2, 0.18 and 0.12. Now, what I want here? I want empirical quantiles. So, with data grouped by classes, we can use a very strange formula to do approximations for the empirical quantiles. But we will not do that because with the table we can obtain. We don't need to calculate. We need only to look to the table. We can obtain some empirical quantiles that are not approximations. So, and with the 5 classes we can obtain 4. So what we need to do? We need to accumulate the frequencies. So I will put here this column, and what I will do here, I will accumulate these frequencies. And this is very easy. For the first class, we don't need to accumulate nothing, okay? Because we have here only 0.3. When we move to the second class now, what we do? We had the relative frequency of the first and the second. So we sum these two relative frequencies. And the sum of this one and this will result here in 0.5. Now when we move to the third class, what we do to obtain the accumulated frequencies? We sum here the simple relative frequencies of the first 3 classes. We only need to sum these 3 values. So 0.3 plus 0.2 plus 0.2. So we have here 0.7, and we continue with this process. Now for the number 4, we sum these 4 relative frequencies, and we obtain here 0.88. And in the last class, we always get the number 1 because we are summing all the relative frequencies, and the sum of all relative frequencies is always equal to 1. Okay. Now, what we do to obtain empirical quantiles? What we do here? We can obtain 4. And the 4 empirical quantiles that are very easy to obtain corresponds to the accumulated frequency. So we can obtain 1 that will be equal to 10. The empirical quantiles will be always equal to the upper limits, okay? To the upper limit. So I have 1 equal to 10, another equal to 20, other equal to 30, and another equal to 40. So we looked to the upper limits of the classes. So, and the empirical quantiles that we can obtain are for example, let me ask you to check here one. What is here the percentile 70? So the percentile 70. The percentile 70 is equal to the empirical quantile 0.7. Okay. And when we can obtain this percentile, we only need to look to this accumulated frequency, the 0.7. Because what is this? What is the meaning of this value here? What is the meaning? We say that 70% or to 70% of the customers we sold less than $30,000 to each customer. So this is the meaning of this. So 30 is the percentile 70. So this percentile is equal to 30. So we can think like this. We put this smaller. We have the sorted data. For example, we can start in 1, 2.5, and so on. And then we will achieve here the value 30. When we achieve the value 30, we have accumulated 70% of the data. So we have here the sorted data, the first 70% of the values. So we have here 70%. And after the 30, we have the remaining 30% of the data. Okay, I put here 30%. So the value 30 divides our data set in two groups. The groups of values that are lower than 30, and we have 70% of values that are lower than 30. And the other group, we have more 30% of values that are higher than 30. So this is the rule of the empirical quantile 0.7 empirical. Okay. Now we can determine obtain here also the empirical quantile 0.3. We looked to the accumulated frequencies to obtain the quantile. So this is important because I will put one exercise asking for one empirical quantile when you will do the test. So you need to know how to do this. So the 0.3 is equal to what? To this upper limit 10. The empirical quantile 0.5 is equal to this upper limit 20. And the empirical quantile 0.88 is equal to what? To this upper limit. Okay? So it's 40. Now we have all the empirical quantiles that are easy to obtain with the table, with the data grouped by classes. So this is easy. I will only write the interpretation of one of them. So because it's similar to all, I will choose this one here and let us interpret this empirical quantile. This is the percentile 88. So how I do the interpretation of this 40. What is the meaning of this 40? We say that 88% of the customers we sold less than, we can put here the equal or, but in this case we don't need to write equal or, but I will put here between brackets equal or. So we sold equal or less than $40,000 than 40. So this is very simple, but when we do this, we understand well what is the meaning of the empirical quantiles.